All right. Continuing. Okay, so we'll start off with some mental arithmetic. Let's do M.A. Quen. We'll leave that for a minute. Forty-seven times 53, 2,491. 47 times 54, 2,538. 96 times 104, 9,984. 213 times 187, 39,831. 9,987 times 10,013, 99,999,831. 73 squared take 27 squared. 4,600, 4,600, or 4,600. 148 squared take 52 squared. 19,800. 73 squared take 26 squared. 4,653. 512 squared take 488 squared. 24,000. 30,002 squared take 29,998 squared. 240,000. Okay, set 2 now. Set 2. 97 squared. 9,609. No, 9,409. 1006 squared. 1,012,036. Alright, so 1006 squared is 1,012,036. 993 squared. 986,049. Okay, 10,004 squared. Oh, 10,004 squared. All right, 100,080,016. 9,995 squared. Okay. Okay, so that's 998,001 plus 999, so 999. Okay, so let's think. For 95 squared, that would be 9025. For 995 squared, okay, I have to try harder then. Alright, let's do it. 995 squared. 990,025, right? 990,025. Okay, so it's gone from 9025 to 990,025. Oh, I get it. So it's going to be 99,900,025. Okay, 48 squared. 2,304. 53 squared. 2,809. 197 squared. 38,809. 504 squared. 254,016. 2,498 squared. 2,498 squared. Well, you know what? A squared take B squared is A add B times A take B. So 2,400, rather 2,500 times 2,496 and then plus 4. That should be the answer. Okay, so 2,500 times 2,496. And the way to do that is to multiply the first by 4 and then divide the second by 4. So that's 10,000 times 624, right? So 6,240,000. And then you have to add 4. So 6,240,004, right? Okay, set 3 now, set 3. 85 squared. 7,225. 115 squared. 13,225. 235 squared. 55,225. 995 squared. All right, so earlier on we calculated that this was 990,025. But is it actually? Let me just see. Okay, so 99 squared is 9,801. And then you have to add on 90. So you get 9891. And then you have to add on that. So yes, that's right. 10,005 squared. Okay, so the danger here are the zeros. So it's 100 million plus 100,000 plus 25. 100 million, 100,000 and 25. 63 times 67. Okay, so just do it. 4,221. 63 times 68. Well, you build on your previous work and you add 63 to it, right? Okay, so 4,284. 163 times 167. Okay. So that's 165 minus 2 times 165 plus 2. Which is 160. Which is 165 squared minus 4, don't you know? And 165 squared is 27,225. So take away 4 and you get 27,221. 34 times 74. 2,516. 2013 times 2017. Okay, so 2,000 squared is 4 million. 13 add 17 times 2,000 is 30 times 2,000, which is 60,000. So 4,060,221. Okay. And now back to mathematics. Back to mathematics. All right, so vectors. All right, okay. Okay, so A and B have position vectors j and 6i plus 4j respectively, and P divides AB in the ratio of 2 to 1. So find P. Okay, so we need to find out how to get from A to B first. And what you do is you do 4i plus 5j. No, that's wrong. No, wait. Okay, say it again. All right. Points A and B have position vectors j and 6i plus 4j respectively. P divides the line segment AB in the ratio 2 to 1. So find P. Alright, so I see the mistake now. So to get from A to B, you have to do 6i plus 3j. Alright, and then divide that into 3. So that would be 2i plus j. and then double it, so 4i plus 2j, and then add that on to a, right? All right, then it would be 4i plus 3j. So 4i plus 3j is a position vector of p when p divides the line segment AB in the ratio 2 to 1, and where A and B have position vectors j and 6i plus 4j respectively, right? Yeah, that's right. Given that the vectors 2i add 3j and lambda I take 6j are parallel, find lambda. Well, the second vector is just a scaled up version of the former. And so it's going to be -2. It's going to be scaled up by -2. Okay, and so you have to multiply 2 by -2, and so you get -4. So -4 is the value of lambda when 2i add 3j and lambda I take 6j are parallel. Find the unit vector in the direction of 6i take 8j. So the magnitude of this vector is 10. And so the unit vector in that direction is 0.6i take 0.8j. So 0.6i take 0.8j is the unit vector in the direction of 6i take 8j. A particle has a position vector of 2i add 3j, and it moves with a velocity vector of 4i minus 3j. Find its position vector after 2 seconds. So we just have to double the velocity vector, so we get 8i minus 6j, and then we have to add that on to the initial position vector. So 2i add 3j plus 8i minus 6j is 10i minus 3j. So 10i minus 3j is a position vector after 2 seconds of the particle which started out at 2i plus 3j and moves at what? 4i minus 3j. That's its velocity. Okay, great. Chapter 12, differentiation. Find the limit of 3 at h all squared, take 3, take h all squared over h as h tends to 0. Right, so on the numerator, if we expand 3 at h all squared, we get 9 at 6h at h squared. And if we expand 3 take h all squared, we get 9 take 6h at h squared. And if we subtract the latter from the former, well, h squared cancels out on both. And then we have 6h on the first minus 6h for the next. So we have 12h. And then the constants, well, those cancel out as well. So we have 12h over h, which cancels out to give us just 12. So 12 is the limit of 3 at h all squared, take 3, take h all squared over h as h tends to 0. Given y equals 2 over root x, find dy by dx at x equals 4. Okay, so y equals 2 over root x. So y equals 2x to the half. And differentiating that, or rather 2x to the negative half. Okay, so differentiating that, we get negative x to the negative 3 over 2. And then we have to substitute 2 into that. Alright, so we have to find 2 to the negative 3 over 2. Alright, so 2 to the negative 3 over 2. Well, first I'm going to cube it, so I get 8. And then I'm going to square root it, so I get 2 root 2. And then I'm going to reciprocal it, so I get 1 over 2 root 2. It would be the negative of 1 over 2 root 2. And I think that's fine. So the negative of 1 over 2 root 2 is the value of the derivative of y equals 2 over root. Oh no, that data is missing. Okay, we found an error. Okay, so given y equals 2 over root x, find dy by dx at x equals 4. Alright, so I think the error was we substituted x equals 2 instead of x equals 4. Okay, so y is equal to 2 over root x. In other words, y is equal to 2 times x to the negative half. So let's differentiate that now. So dy by dx equals negative x to the negative 3 over 2. And now let's substitute in 4 for x. So square root 4 to get 2, cube it to get 8, and reciprocal it to get 1/8, and then it will be negative 1/8. Okay. So if y is equal to 2 over root x, the value of dy by dx at x equals 4 is negative 1/8. Find the equation of the normal to y equals x squared minus 2x at x equals 2 in the form y equals mx at c. So first we have to differentiate it to find the tangent gradient. If y equals x squared minus 2x, then dy by dx equals 2x minus 2. Let x equal 2. Then the gradient of the tangent is 2. And so for the normal, it will be negative a half. Now, we don't know what the point is. So we have to substitute 2, don't we? All right, so we get 2, 0. So y equals a negative a half x plus c, and the point that we have is 2, 0. All right, so c is 1. So y equals negative a half x plus 1. So y equals negative a half x plus 1 is the equation of the normal to the curve y equals x squared minus 2x at the point x equals 2. Right? Right. Find the set of values of x for which y equals x cubed minus 3x is decreasing. Okay, so it's decreasing when dy by dx is negative. So dy by dx equals 3x squared minus 3. 3x squared minus 3 is less than 0. When is that true? Solve it. 1 and negative 1. All right, so it's any value between negative 1 and 1. Strictly. So for x between 1 and negative 1, y equals x cubed take 3x is decreasing. Okay. Given y equals x plus 4 over x, find d2y by dx squared at x equals 2. So y equals x at 4 over x. So dy by dx equals 1 take 4x to the negative 2. d2y by dx squared equals 8x to the negative 3. Now let x equals 2. Alright, that's 8 times an eighth, which is 1. So 1 is the value of d2y by dx squared at x equals 2 for y equals x plus 4 over x. Oops. Find the y coordinate of the minimum point of y equals x cubed, take 3x squared. The y coordinate of the minimum point. Alright. dy by dx equals 3x squared, take, okay. Right, we'll just try it again. Find the y coordinate of the minimum point of y equals x cubed, take 3x squared. dy by dx equals 3x squared, take 6x. 3x squared take 6x will have to equal 0. So x squared take 2x will have to equal 0. X, open brackets, x minus 2, so we have two possibilities, 0 and 2. Now you don't know which one's which, so you have to find d2y by dx squared. Okay, so just a reminder that y equals x cubed minus 3x squared. So dy by dx equals 3x squared minus 6x. So d2y by dx squared equals 6x minus 6. Sub 0, we get a negative. Sub 2, we get a positive. And the minimum occurs at the positive, and therefore it's at x equals 2. But they asked for the y coordinate. So we have to sub 2 into the original function, which was y equals x cubed minus 3x squared. So cube 2, and then take away 3 times the square of 2. So 8 take 12 is minus 4. So negative 4 should be the y coordinate of the minimum of y equals x cubed minus 3x squared. Okay. A box has a volume V, where V equals 12x, take x cubed. Find the maximum volume V. dV by dx is 12x, take x cubed, right? Right, try again. box has a volume V where V equals 12x minus x cubed. Find the maximum volume of the box for x greater than 0. Alright, dv by dx equals 12 minus 3x squared. Right, 12 minus 3x squared has to equal 0. So 4 minus x squared equals 0. So 2 take x times 2 plus x equals 0. So x equals 2 or negative 2, but we already know that x has to be greater than 0, so x equals 2. And so now find the volume. Okay, so 12 times 2, take 2 cubed, and that's 16. So for a box whose volume V, where V equals 12x take x cubed and x is greater than 0, the maximum volume is what? 16. Find the values of x for which the gradient of y equals x cubed take x is 11. dy by dx equals 3x squared take 1. 3x squared take 1 equals 11. So 3... That can't be right. Did I read that correctly? Find the values of x for which the gradient of y equals x cubed take x is 11. Yeah, that's right. Okay, so dy by dx equals 3x squared take 1. And 3x squared take 1 equals 11, so 3x squared... Oh, I get it. I subtracted 1 instead. So 3x squared is equal to 12. So x squared is equal to 4. So x is 2 or negative 2, right? So for the function y equals x cubed minus x, to have a gradient of 11, x has to equal 2 or negative 2. Okay, 13. Find the integral of 6 root x dx. 6 root x is 6x to the half. So just apply the power rule. So that would be 4x to the 3 over 2. Or 4 times the square root of x cubed plus c. So 4x to the 3 over 2 plus c is the integral of x 6 times the square root of x dx. Find the integral of 6x to the negative 3 dx in the form ax to the n plus c. I'm not sure if I read that right. Yes. Find the integral of 6x to the negative 3 dx in the form of ax to the n plus c. Okay, so negative 3x to the negative 2 plus c. So negative 3x to the negative 2 plus c is the integral of 6x to the negative 3 dx. Is that it? Try again. Okay. Given dy by dx equals 3x squared take 4 and y equals 5 when x is equal to 1, find y in terms of x. Okay, so integrate that. X cubed take 4x plus c. So y equals x cubed take 4x plus c. Now y is 5 when x is equal to 1. So 5 equals x. 5 equals x cubed take 4x plus c. 5 equals 1 cubed take 4 times 1 plus c. 5 equals negative 3 plus c. C is equal to 8. So y equals x cubed take 4x plus 8. So y equals x cubed take 4x plus 8 when dy by dx equals 3x squared take 4 and y is equal to 5 when x is equal to 1. Okay. Evaluate from negative 1 to 2 3x squared add 1 dx. Okay, so first integrate it to get x cubed at x. Sub in 2, sub in negative 1, then subtract the latter from the former. Sub in 2 and you get 10. Sub in negative 1 and you get negative 2. So 10 minus minus 2 is 10 plus 2, so 12. So when you have to integrate from negative 1 to 2, 3x squared add x, 3x squared add 1 dx, The answer should be 12. Find the area enclosed between the curve y equals x squared minus 4x and the x-axis. So first find the roots. For x squared minus 4x, we have x open brackets x minus 4. So 0 and 4. Now integrate from 0 to 4 x squared minus 4x. The integral is a third of x cubed minus 2x squared. So sub in 4. Alright, a third of 64 is 21 and a third. Oh no, that feels wrong. That's not correct. Do it again. Find the area enclosed by the curve y equals x squared minus 4x and the x-axis, right? Okay. So integrate from 0 to 4 x squared minus 4x dx. The integral is a third of x cubed minus 2x squared sub in 4. (21 and a third) take 8. 13 and a third. So it appears that the area of the region enclosed between the curve y equals x squared minus 4x and the x-axis is 13 and 1/3. Find the total area between the curve y equals x cubed and the x-axis from -1 to 1. Okay, so yes, I understand. So it's an odd function, so we need to only integrate from 0 to 1 and then double it. The integral of x cubed is a fourth of x to the 4. And so it's a quarter, and then you have to double it till you get a half. So a half should be the area of the region enclosed by the curve y equals x cubed and the x-axis between x equals -1 to x equals 1, right? Right. Evaluate the integral from 1 to 4 of x at 1 over root x dx. Okay, so you have to split it up. So it becomes root x to the half plus x to the negative half, and then integrate that 2/3 of x to the 3 over 2 plus 2x to the half So now 9 1/3 at the top. Two and 2/3 at the bottom. So 6 and 2/3. So 6 and 2/3 appears to be the integral from 1 to 4 of x. Appears to be the integral of 6 and 2/3 appears to be the integral from 1 to 4 of x at 1 over root x dx. All right, chapter 14. Solve 2 to the x at 1 equals 8 to the x. So 2 to the x at 1 equals 2 to the 3x. X at 1 equals 3x. 1 equals 2x. X equals a half. So 2 to the x at 1 equals 8 to the x is solved by x equals a half. Find the gradient of y equals 5 times e to the 2x at x equals 0. dy by dx equals tan e to the 2x sub 0 tan. So tan appears to be the gradient of the function y equals 5e to the 2x at x equals 0. A temperature function is modeled by let big T be temperature and small t be time. So big T equals 20 plus 60 times 0.5 to the small t. Find small t, the amount of time passed, when big T, the temperature, is 35. Alright, so essentially we're solving the equation 35 equals 20 plus 60 times 0.5 to the t. Okay, so if that's the case, then 15 equals 60 times 0.5 to the t. So 1/4 equals 0.5 to the t. And the answer to that is simply 2. So the amount of time that's elapsed is 2 temporal units when temperature is 35 thermal units for the temperature model. Temperature equals 20 plus 60 times 0.5 to the time. Evaluate log base 4 of 8. So to what power must 4 be raised to get 8? Well, you have to square root it and then cube it. And so the answer is 3 over 2. Write 2 log base 3 of 6, take log base 3 of 4 as a single number. So 2 log base 3 of 6 is log base 3 of 6 squared, which is log base 3 of 36. Then it becomes log base 3 of 36, take log base 3 of 4, which is log base 3 of 36 over 4, which is log base 3 of 9, which is 2. So 2 is the value of 2 log base 3 of 6, take log base 3 of 4. Solve 2 to the 2x, take 6 times 2 to the x plus 8 equals 0. Let y equals 2 to the x, then y squared take 6y at 8 equals 0. So y take 4 times y take 2 equals 0. So y is either 2 or 4. Now, if 2 to the x equals 2 or 4, then x is 1 or 2. So for 2 to the 2x, take 6 times 2 to the x plus 8 equals 0. To be solved, we have to set x equal to 1 or 2. Solve 2 ln x equals ln 9. Alright, so by the laws of logarithms, it would be ln of x squared equals ln of 9. So x squared equals 9. Now, the temptation here is to say -3, but that is not allowed. So the actual answer is just simply 3. So for 2 ln x equals ln 9, the answer is simply 3. Alright, and that concludes it.